Welcome to my algebra class. We are on chapter 3, section 6. We're going to be solving word problems with two unknowns, and we're going to use charts to do this. This is another method of solving problems to organize your work. So this problem is an example of what you're going to be doing on your assignment. It says find the number of calories in an apple and in a pear. It gives you the information that a pear contains 30 calories more than an apple, and also that 10 apples have as many calories as 7 pears. I'm going to use the first sentence to build my unknowns. Since they're building on, the last thing mentioned is the apple, I'm going to let x be the amount of calories in an apple. And a pear contains 30 more, so x plus 30 is the pear. We need to know how many you can only have one variable, so this column has to be completely filled in with numbers. The number of fruit, they gave us that information in the second sentence. There are 10 apples and there are 7 pears. To find the total calories, you times these together, so this is 10x. And 7 times this, remember you have to multiply everything by 7, so that would be 7x plus 7 times 30 is 210. The second equation says that the 10 apples have exactly the same number of calories as the 7 pears. So our equation is 10 apples, 10x, equals 7x plus 210. Getting the variable on one side, remember if the variable, the term with the variable has by itself on one side, you need to move the other term with the variable to that side. So we're going to subtract 7x to eliminate it on the right. So we get 3x equals 210. Dividing by 3, we find out that x equals 70. So x was the apples, so there are 70 apples. And 70 plus 30, there were 100 pears. Excuse me, that's not how many apples there were. 70 calories in an apple. And there's 100 calories in a pear. Okay, that's the example, and we're going to start doing the evens, so you need your paper for that. So full heading, skip a line. The title is page 122, problems 1 to 8. And we're using charts on the majority of these. So problem number 2. It says, find the number of round-trip commuter rail tickets sold. There are 30 times as many round-trip tickets as 12 ride tickets sold, and the total number of tickets sold represents 1,440 rides. So we have to reproduce the chart. So take your time and make the chart right now. Use one line of the paper for one line of the work, the chart. So we have the hours per shift. We have the number of shifts. Whoops, I'm sorry, I'm doing the wrong problem here. I'll get rid of that. Number 2 was about tickets. So this is rides per ticket. And number of tickets sold. And this is the total rides. And we have, in these commuter rail tickets rides, we have a 12 ride ticket. That's one type. And we have a round trip ticket. So the number of rides for a 12 ride ticket obviously is 12. And a round trip, you go to and you come back, so it has 2 rides on it. And it said there were 30 times as many round trip as 12 ride tickets. So we're building on the 12 ride tickets, so I'm going to let X equal the 12 ride tickets. And there were 30 times as many round trips, so that'd be 30X. So the total number of rides is 12X for the 12 ride tickets, and the total number of rides for the round trip would be 60X. Multiply them together. The equation comes from the second sentence. The total number of tickets sold represented 1,440 rides. So we take all the 12 ride tickets, which is 12X, add it to all the round trip tickets, 60X. It totals 1,440 rides. Those are like terms, so we add them together and we get 72X equals 1,440. Solving for X, divide both sides by 72. And using our calculator, wherever it might be, we take 1,440 divided by 72, and our answer is 20. So X, which is the number of 12 ride tickets, is 20. That's the 12 ride. Now, these problems become difficult because you got to go back and see exactly what they wanted. There are 20 12 ride tickets. However, they wanted the number of round trip commuter rail tickets, and that was 60X. So if there were 20 12 ride, we need to take 60 times 20. Excuse me, 30 times 20. Because there were 30 times as many round trip tickets, so 30 times 20, there were 600 round trip tickets. Okay, problem number 4. Find the amount of time Joel spent watching space adventure movies. He saw twice as many 1.5-hour space movies as he did 2-hour mysteries. He spent a total of 15 hours watching movies. So the question says find the amount of time he spent watching space adventure. So keep that in mind as we do the problems. So we're going to make our chart. So this is length of movie. This is the number of movies. And this third column will be our total time at the movies. We have 2 types of movies, space and mystery. It said, the first sentence said he saw twice as many 1.5-hour space movies as he did 2-hour mysteries. So we know the movie lengths. So the length of a space movie is 1.5. And the length of a mystery is 2. And it said he watched twice as many space movies as he did mysteries. So they're building on mysteries. So we'll let X be mysteries. And space was twice as many, 2X. So if I take 1.5 times 2, that's 3 halves, times 2X, cancel, I get 3X. Or you could take 1.5 times 2, it's still 3X. And then 2 times X, the total time at the mysteries was 2X. And problem number 2 gives us our equation, or sentence 2 rather. He spent a total of 15 hours watching movies. So 3x plus 2x, adding all the total time he watched movies, is actually equal to 15 hours. Collecting like terms, we get 5x equals 15 hours. Divide by 5. And we find out that x is 3 hours. Now remember, x is the number of mystery movies he watched, but we wanted to find out find the amount of time he spent watching Space Adventure. So this is the total time he watched Space Adventure. So we're going to take 3 times 3 and find out, because this is x. He spent 9 hours watching Space Adventure movies. Problem number 6 says find the number of calories in a stalk of celery and in a carrot. So we get to make the chart this time. And we did a problem similar to this in the explanation of this section. So our columns would be the number of calories for each type of vegetable, the number of each vegetable, and the total calories. And we would find the total calories by timesing. And the 2 types of vegetables we have is a celery and a carrot. It says a carrot has 13 calories more than a celery stalk. They're building on the celery, so that would be x. And a carrot has 13 more calories, so x plus 13. The second sentence tells us we have 5 carrots and 10 celery stalks. So the total number of calories in the celery would be 10x. And for the carrot, remember, use your distributive property. 5 times x is 5x. Plus 5 times 13 is 65. And they tell us that the 5 carrots, 5x plus 65, and the 10 celery stalks plus 10x has to equal 170 calories. Collecting like terms, we have 15x plus 65 equals 170. Solving for x, undo the addition, subtract 65. And we get 15x equals 105. Divide by 15, and x comes out 7. Now x is the number of calories in a celery. They want us to find the calories in both. So we have 7 calories in celery. And x plus 13 is the number of calories in the carrot. So 7 plus 13 equals 20 calories in the carrot. And problem number 8 says the length of a rectangle is twice its width. A second rectangle, which is 8 centimeters longer and 3 centimeters narrow than the first triangle, has a perimeter of 154. Make a sketch of the rectangles expressing all dimensions in terms of W. Find the dimension of each rectangle. On number 8, I would not use a chart. I would draw the pictures of that. So geometry problems, you draw pictures. So we have 2 rectangles. So we'll draw this one and this one. It says the first one, the length of a rectangle is twice its width. So W, and this would be twice its width, the length 2W. Then you have this second rectangle, which is 8 centimeters longer, so that would be 2W plus 8. And 3 centimeters narrower would be W minus 3. Then they tell you that the first rectangle has a perimeter of 154. Now remember, on previous problems, to save myself work, I took half the perimeter and did one length and one width. So I only went to up the width and over the length, so halfway around. So I'm going to take one width and one length, 2w plus w, and set it equal to 77. So that's 3w equals 77. Oops, I did the wrong perimeter. I knew something was going wrong. All right, the perimeter of the second one is 154. So half of it would be 77. So one length and one width, 2w plus 8 plus w minus 3 has to equal 77. Collecting like terms, I have 3w, positive 8, negative 3 is plus 5, equals 77. Solving for w, subtract the 5 from both sides, undo the addition. So I get 3w equals 72. Divide by 3, and w equals 24. So they want the dimensions of all the rectangles. So this one has a width of 24. The first one has a width of 24. Its length is 2w, which is 2 times 24. So it's 48. So its dimensions are 24 and 48. Let's make that a little bit neater. And the second rectangle has a length of 2w plus 8. So that would be 2 times 24 plus 8, which is 48 plus 8, which is 56. So that's its length. And its width is w minus 3, so that'd be 24 minus 3, which is 21. So the first rectangle has dimensions 24 and 48, the second one 56 and 21. And that concludes the evens. Be sure and get help as you need for the odds and check your answers in the back.